Hey there, Akal here and welcome back to my channel. In this video, we are going to talk about inter-AC, inter-VLAN communication. So we are going to implement a router on a stick. So let's jump into and see the requirement. In the background, there are two branches in a company. We want to make the configuration to let these two branches to communicate with each other. So router 1 here will act as the DHCP server to assign IP addresses to our devices. So we're going to configure sub interfaces on that router. So this is how our topology will look like. Gig 00.1 is going to be given an IP address of 192.168.10.254. That is going to act as the gateway for the VLAN 10, and gig 002.2 given an IP address of 192.168.20.254, and it's going to act as the gateway for VLAN 20. Now let's see the requirements. Configure IP addresses and names of network devices according to the addressing table. Number 2, create VLANs on switches, VLAN 10 and 20. Enable STP on all switches and configure them to work in STP mode. Create ETH trunk, configure the link aggregation with the name 1, switch 1 and switch 2. Configure ETH trunk to work in static LSP mode. Only allow VLAN 10 and 20 to pass. Configure router on a stick to implement inter-VLAN between VLAN 10 and 20. The tip here is router 1 has only one physical interface connected to switch 1. Configure the interfaces as trunk interfaces to transmit VLAN 10 and 20 packets. Configure different logical sub interfaces on R1 as the gateways of different VLANs. Create sub interfaces on R1 and configure IP addresses for sub interfaces. Either sub interface belongs to one VLAN respectively. Number 6, router 1 act as the DHCP server to dynamically allocate IP addresses to PC1 and PC2. Create pool 1 and pool 2, both the global address pools. Router 1 works as gateways of VLAN 10 and 20. Network segment of VLAN 10 is 192.168.10.0/24. Network segment for VLAN 20 is 192.168.20.0/24. The DNS, we are going to set the Google DNS, that is 8.8.8. List time is going to be 2 days for both pool 1 and pool 2. Then last part here is telling us to configure telnet server. This last point we are not going to configure because telnet server is insecure protocol. Nowadays we implement SSH, that is secure shell. So in my next video, I'll show you how you can configure secure shell. So this part of telnet, you're going to ignore it. So at the end of it all, the configuration, PC1 and PC2 should be able to ping each other. So let's just jump straight away into our configuration and do it very fast. I change the device name. This is router 1. Entering router 1, we are going to configure the sub interfaces. So the sub interface for gig 1, we're going to give it a sub interface, so interface G0 /0/1 .1 the first sub interface. After giving that, we give the sub interface IP address or IP address of 192.168.10.254. It's going to act as the gateway for VLAN 10/24. So Then you enable .1q termination, .1q termination, VLAN ID of 10. Then ARP broadcast, enable, and let's display okay. Now let's configure the sub interface .2. So .1q terminate IP address first. Let's give it IP address. We're going to give it IP address of 192.168.20.254/24. And enable .1q termination, VLAN ID 20. Then we enable ARP broadcast, enable. You quit and save the configurations. So yes. After that, we come to these switches and configure layer 2. So that is, we allow the VLANs which are required to pass. As we have said, we have to configure the ETH trunk, and also we have configured the spanning tree protocol. So the spanning protocol will help us curb the loops in the network. So we change and do terminal, and we change the device name. So this is switch 1. Switch 1. First of all, we create the VLANs in batch. So VLAN batch 10, 20. But creating the VLANs, thing is, you're going to create the ETH trunk interface, ETH trunk 1. And ETH trunk 1, you're going to add how many interface 3. So trunk port gigabit 0/0/2 to 0/0/0/4. And the trunk port is allowing VLAN 20 and 10 and 20 to pass. So port link type is port link type trunk, and you tell it to allow VLAN 10 and 20 to pass. So port trunk allow pass VLAN 10 and 20. Then we are told that the trunk port uses LSCP mode, so mode LSCP static. And changing the trunk mode. Display this. And then changing the trunk working mode. There is quit, and let's clear that. Let's clear the clear. Configuration interface ETH trunk 1. So yes. So let's create now that interface ETH trunk 1. And do shutdown, then mode LSP static then changing the working mode. Let's be priority 200 and let's see interface it's trunk 1. Port link type trunk port trunk. Now pass VLAN 1020. And let's see now if that command will be able to pick up mode. Or let's be static so that command has picked on this other switch. So after configuring the mode LSCP, the thing is we add the trunk interfaces into that eth trunk, so 0/0/0/2 to 0/0/4. After that, configure the maximum active bandwidth. So number we set it to 2. Then we configure the load balance. So load balance is source destination mark. Let's display this. So we enable that and now quit and save the configuration and also come to this other switch and let's see if now we'll be able to configure the mode LFC static 5. So meaning that this our switch here has an issue. So the thing we do, we remove this our switch and replace with a new switch. And bring this switch here. So let's get our switch here and see if it will be able now to pick the eth trunk interface. So we undo terminal, monitor, and we change the device name. So this one I'm going to name it switch 1. Create the VLAN batch 1020. Sorry. Create the VLANs in batch form, so 1020. after that I create the interface eth trunk, and you add the interface into the logical eth trunk. So interface eth trunk 1, interface eth trunk 1. So port link type, this is a trunk port. Port link type trunk, and tell it port trunk to allow pass. Port trunk tell it to allow pass VLAN 10 and 20. So those are the VLANs from which you want the PC to be able to communicate. VLAN 10, 20. Then now let's configure the mode and see if it will be able to accept. So it's okay. So meaning that our switch was the issue. So after that, I add the interfaces into the logical eth trunk. So trunk port gigabit Ethernet 0/0/2 to 0/0/0/4. Then configure the maximum bandwidth. So maximum active number I set it to 2, and then the load balance. So the load balance mode, you're going to set source destination mark, and just display this and see what is on that eth trunk. So as you can see, everything is set. Then you quit. Set the device priority. So LSP priority, give it 100. So the lower the priority, the higher the preference. So switch 1 here is going to act as the master, then switch 2 here is going to act as the backup. Okay, VLAN batch 10, 20. VLAN batch 10, 20. Interface eth trunk 1, and display this and see what's configured on that eth trunk. So on this other side, the eth trunk has been set up. So I quit and enter the interfaces that have been added to the eth trunk. So interface gig 0, so 0/2, display and see what's on that interface. It has been added to the eth trunk. So after that, I give it the LSP priority, the interface based priority, LSP priority of 100. The reason why we are giving the priority is because we want some interface to act as the active interface, and the other to act as the backup interface. So the one that's going to act as the backup interface will use the default priority, that is 32,768. So gig 3 also will give it a priority of 100. Then you quit. You save the configurations. Say yes, and come back on this other switch and give the interface which will act as the active, the interface priority. So interface gig 0/0/2 LSP priority. We give it a priority of 100. Also gig 3, give it a priority of 100. Then you quit and display the eth trunk. So display interface, display eth trunk 1, eth trunk 1. When you display eth trunk 1, you can see here gig 002 and gig 003 has been selected as the active interfaces, while gig 4 has been unselected. So in case one of the two active interfaces goes down, the backup interface, that is gig 4, should be able to take over the roles of the interface that has gone down. As you can see here, the backup has been given a device priority of 200. So meaning that our eth trunk is set. So now we are going to configure the spanning tree protocol they told us to use STP, but in this case, me, I'm going to use MSTP. That is the multiple spanning protocol, which is the default for the Huawei. Now set the STP mode to MSTP. So this one, the first switch here, we are going to create two instances, that is instance 1 and instance 2. So STP instance 1, instance 1 is going to act as the root primary. Then STP instance 2 is going to act as the root secondary on this switch here, root secondary. After that, you enter the STP region configuration. So the region name we are going to give it to Huawei. Then instance 1 we are going to bind VLAN 10. Then instance 2 will bind VLAN 20. And then active region configure the active region configuration for the configuration to take effect. So now let's display this. Okay, after that you quit, and you also do the same on this other switch here. So say SYS. So STP mode here, it is MSTP, and instance STP instance 1 on this other switch, instance 1 is going to act as the root secondary, and STP instance 2 will be act as the root secondary, root primary. I mean, instance 2 on switch 2 is going to act as the root primary. Then STP region configuration, we give it the region name. Region name you're going to give it Huawei. Then create the instances and bind them into VLAN. So instance 1, bind it to VLAN 10. Then instance 2 VLAN 20. Then create the active region configuration for it to take effect. Region configuration. Then display. Then our STP, I think, should now be up. Now let's configure the interfaces. They are the interface that connect us to the terminal. So the access interfaces, that interface gig 5. So create interface gig 0/0/5. We give it the link type. So port link type. So this is a port link type. This is an access port. Then access port, why? Because it connects the terminal, that is the end user devices. So port link type access. Then port default PC1, we're going to give it VLAN 10. So then save. Then come to this other switch and configure it and enter interface gig 5, gig 0/0/5, port link type. This also port link type. This is also an access port, and tell it port default VLAN 20. Okay, save config. After that, also configure gig 1 here. The gig 1 is that connect the switch to the upper router. So you tell gig 1 also to allow VLAN 10 and 20 to pass the interface VLAN, not VLAN, so interface gig 0/0/1. So port link type, this is a trunk which is allowing pass port trunk, allow pass VLAN 10 and 20 pass. Okay, and make sure you also save your configurations on the actual device. Then we were told here that switch router 1 here, router 1 will act as the DHCP server, to assign IP addresses to the PCs. What is the IP addresses that enable the PCs to be able to communicate? So on router 1 here, we configure the .1 queue termination so that in case it receives packets from VLANs of the VLAN that we configure on those sub interfaces, it will be able to let them pass. Now on that switch, going to configure our DHCP. So DHCP, enable it in the global view. Because we already configured the sub interfaces, it's the sub interface that is going to help the PC in different VLAN be able to communicate, because we will configure the gateways for the different VLANs on one physical interface. Now let's enable DHCP. So they said we configured it in a pool base, so IP pool, we said pool 1, IP pool 1. So IP pool 1, we give it the network of 192.168.10.0, mask of 24. Then our gateway will be gateway list, to give it of 192.168.10.254. After that, we are told to give a DNS list of 8.8.8. Then the next thing we are going to configure on that pool. Let's display this and see what remains on that pool. So we are told also to configure the list day, so the number of days in which you are going to use your IP addresses. So when that the days as they run out, you should be able to apply for a new IP address. So list day, we are told to configure list day of 2. Now let's display. So yeah, okay. After that, I configure the second pool. So quit and configure the second pool. Pool 2, and in that pool configure the network of 192.168.20.0, mask of 24. Then the gateway will be 192.168.20.254. The DNS list, we're going to give it 8.8.8.8. Then the list day, we set the list day to 2. as the practical suggested. After that, let's display and see what's configured on that. So as you can see here, our DHCP set. So to enable the DHCP to be able to reach our pieces here, you enter into the sub interfaces, and you select the global. So interface 0/0/1.1 interface 0/0/0.1. Let's display and see if it has an IP address. So it does have an IP address. So select DHCP, select global, then you enter gig 2. You also tell it to select DHCP, select global. Control, save your configuration, say yes. And let's capture packet on that gigabit 1. Enter the switch here and you capture packet on gig 1 and see how the DHCP is able to do the discoveries. Let's see on this switch here if maybe it has obtained an IP address. So IP config. Alright, good, nice. So this device here has obtained an IP address of 192.168.10.253. And this side here, let's also see if it has obtained an IP address. Select the DHCP and you apply. Then you come into the command line, command prompt. So IP config has also obtained an IP address of 192.168.20.253. So because you know that IP address, you can decide to assign that IP address permanently. So by using you come back to that on your router here and enter IP pool pool 1. Display this. So okay, quit, and also display DHCP statistics. So in the DHCP statistics, 2 discoveries were sent and the request 2 requests have been made. 2 requests have been made. So at times you can configure the PC to have the permanent IP address, so you just bind it to its MAC address. Let's see how we've captured packet on that gig 1. So come to gig 1 here. Still capturing packets, so means that okay. Let me scroll up. When you see here in our Wireshark here, how we are capturing packets. So in the first case, the DHCP client first sends a discovery. So it sends a discovery to the DHCP server to request for an IP address. Then the DHCP offers an IP address. The DHCP server tells the client that can you use this IP address of 192.168.10.253. So that's the offer. Then now the DHCP client is going now to make the request. To request, okay, you can give me that an IP address of 192.10.253. Now the DHCP server now replies, okay, now use that IP address of 192.168.10.253. So that is how the exchange is taking place on that on the DHCP server and the DHCP client. So the gratuitous ARP here is just help to ensure that there is no IP address conflict. So only one IP address is assigned to one device. So let's go back here and continue with our practical. Our main aim was to enable a communication from VLAN 10 and VLAN 20 to be able to communicate. So because this guy already obtained an IP address of 10.168.10.253, let's check the IP address of this guy and try to ping and see if they are able to communicate. So this guy is .253. So we are going to ping 192.168.10.253. So that's the PC on the other network. So as you can see, it's able to ping, so meaning that it's trying to communicate with the gateway. So the gateway that is 192.168.20.254. when it communicates with the gateway, it tells it, okay, I know the network, this network you want to reach. So it tells you want to reach network of VLAN 2 or VLAN 10. So it forwards the packet to VLAN 10. You do the same to this other guy here and try to ping the other PC on the other network. So ping 192.168.20.253. It should be able to ping successfully, meaning that the DHCP we set is running, is in an up state, and also the gateways we set on the sub interfaces of the router are also running actively. So that was the main demonstration of this practical. That was the thing we want to implement. At least implementing VLAN communication when we have a router on a stick. So there are different ways you can implement VLAN communication. It's either a router on a stick or a sub VLAN interface. Also, you can use the VLAN interface. So thank you guys for watching our videos. Remember to subscribe for more content. So